Hey guys, this is going to be the last video on some examples of probability. I'm going to really do some problems that deal with independent because that's a commonly asked question. So this is actually from AP Statistics examination, but I'm sure everyone can do it. So it says, the table below shows the political party registration by gender of all 500 registered voters in Franklin Township. So we have this table, and we have this here, we have this here, and then you guys remember from the other videos, we have the total. So there's the 500 they were referring to. Letter A, given that a randomly selected registered voter is a male. Okay, so let's get rid of this. Given that the registered voter is a male, so out of these guys, out of the 200, what is the probability that he is registered to party Y? So this, or this. I'm gonna choose this one. So the probability, I'm gonna do the notation, given male, so it has to come after the line because that's going to be our denominator. What's the probability that he's registered for party Y? So out of the 200, I'll pick 48. And that's it. Yep, that's an AP question. Letter B. Among the registered voters of Franklin Township, are the events is a male and registered for party Y independent? Justify your answer based on probability. Well, we know how to show independence. Two events are independent if their intersection is equal to the product of the two probabilities. And it doesn't matter if you put male and Y or Y and male. So what is the probability? Let's erase this. What is the probability of choosing a male? Well, go all the way to 200 out of 500. Now remember, this is not, when we do this here, this is not a conditional probability. This is just anyone selected. What's the probability that anyone you select is from the party Y? Well, this is party Y, so that's 168 out of 500. Now, does that equal to their intersection? Do you guys remember how to find the intersections? You go to party Y, you go to male, and it's going to be this here. So obviously I'm going to have to erase it, but you just have to see where they intersect. Okay, so they're going to intersect right there, and that's going to be 48 out of 500. So we can't just say, oh, there's no way these two are equal or not equal. You're going to have to actually show it. So you take your calculator and you say 200 times 168, you could hit the enter button, divided by 500 times 500, or 500 squared. And that's going to give you 0.1344. And 48 out of 500 is going to be 0.096. And I knew that because double it gets you to 1,000. So since these two are not, since the probability of Y and M does not equal the probability of M times the probability of Y, they are not, you have to explain, they are not independent. You have to explain why they are not. You can't just show this probability. So I hope that was easy enough. So to show independence, you're going to have to, first of all, to show independence, everything should be out of the total. Okay? So let's try another one. Here. Let's try this. Okay. This is a simple random sample of adults living in a suburb of a large city was selected. The age and annual income was recorded. The resulting data are summarized, and we also have the total, okay? What's the probability that a person chosen at random from those in the sample, so anybody will be in the age of 31 to 45. Well, anyone chosen, doesn't matter how much you make, anyone, the probability of 31 to 45 is going to be this guy right here, and that's 89 of them. Well, that's not a probability. It's out of the total. Why is it out of the total? Because it's not a conditional probability. It doesn't say given. Next one. What is the probability that a person chosen at random from those in the sample whose incomes are over $50,000? So now they don't want everybody. They want only those whose incomes are over $50,000. So they want that right there. So that's going to be out of the 96. So either him, or him. What is the probability that the person will be in the 31 to 45 age group? So that's this guy here, because that's my... So it's 31 to 45 given they make more than 50K. And that's how you do that. Well, are these two independent? Let's find out. Or what two independent, I should be more clear. Is being 31 to 45 and making over $50,000 independent? Well, let me see. Does 31 to 45 and greater than 50K, does that equal, remember that question mark? Because we don't know if it's equal or not. Does that equal the product of the two? Now remember, when you're showing independence, you need to use the total. So out of 207, where does 31 to 45 and greater than 50 meet? Let me pick a different highlighter. So there's 31 to 45, there's 50, they meet at 35. So that's going to be this guy here. And now 31 to 45 is going to be 89 over 207 times more than 50 is going to be 96 over 207. And I'm certain those two are not independent because those two probabilities don't match. Okay, so that's how we do some of these examples on independent, the conditional probability given, the or. And one other thing that we haven't discussed much, but mutually exclusive is important also. That means their intersections don't overlap. And that means that basically if you make anything, if you, let's say, are in this column, and this column, and this column, these three events are mutually exclusive from one another. Similarly, you cannot be in the group 46 to 60, 31 to 45. So those two are mutually exclusive. I hope all these videos helped. You can leave comments on any questions you want me to answer for you, and I will make a video for those questions. Good luck.